Hello guys, in today's video I want to talk about something that a lot of people honestly ignore when they buy a high-end PC monitor, and that is the DisplayPort cable they're gonna use with it. Here I have this Silkland DisplayPort 2.1 DP80 cable. I want to use it as a real example of what I will personally check before trusting any cable with a setup like 4K at 240 Hz. Because when you connect a monitor and the screen turns on, it's very easy to think that everything is working perfectly. But that does not always mean the connection is running at the full bandwidth your GPU and monitor can support. And with normal monitors, maybe this does not matter much. If you are running it at 1080p, 1440p, or a lower refresh rate, many DisplayPorts cables can be completely fine. But once you start using something like 4K at 240Hz refresh rate with HDR on 10-bit color depths, the cable becomes much more important. Here I am using an RTX 5090 connected to a Samsung Odyssey QD OLED G80SH. This is a 4K 240Hz refresh rate monitor, and I'm actually going to review this monitor pretty soon, so stay tuned for that. But for this video, it's exactly the kind of setup where I will not ignore the cable. As you can see in Windows, the monitor is running at 4K 240Hz refresh rate with 10-bit color and HDR enabled. And inside the NVIDIA settings, we can also see the display connected through DisplayPort using the native 4K resolution at 240Hz refresh rate with 10-bit color and full dynamic range. So from Windows and NVIDIA settings, everything looks correct. The resolution is right, the refresh rate is right, the color format is right, HDR is enabled. But here comes the problem. Windows does not really show the full DisplayPort link speed in a clear way. So if you want to see what's actually happening between the GPU and the monitor, one useful tool is Tech Power Up GPU Z. It's a free application, and inside GPU Z, you can go to the Advanced tab, and here you can check the real DisplayPort link information, the current link rate, the maximum link rate, and how many lanes are being used. With this, like for example, Silkland DP80 cable, the link rate shows 20 gigabits per second, and it's using all 4 lanes. And this is exactly what I wanted to see. DP80 basically means up to 80 gigabits per second. More specifically, it's 20 gigabits per second across 4 DisplayPorts lanes. So 20 times 4 gives you the full 80 gigabits DisplayPort link. In this case, it's not only the cable saying 80 gigabits per second on the package or on the product page, the PC and the monitor are actually transferring the full DP80 UHBR20 connection, which stands for ultra high bitrate. And this is important because not every cable will do that, even if the monitor still works. To show you what I mean, I also tested another DisplayPort cable. It's not the Silkland cable, it's a different one I used only for comparison. And the interesting thing is that this other cable still works. The monitor turns on, Windows will detect it. In many cases, you may not immediately notice anything wrong. But when I check it in the GPU Z, the result is different. Instead of showing 20 gigabits per lane, this other cable shows a maximum link rate around 13.5 gigabits per lane. And during the test, the current link rate is around 10 gigabits per lane, so 40. This is a good example of why the cable actually matters. It does not mean the other cable is completely bad. For many setups, it could still be totally fine. But for a monitor like this, 4K at 240Hz, I would not just use any random cable and assume it's giving me the best possible connection. Now, one thing that is important to understand here is DSC, which means display stream compression. This is one of the reasons why a lower bandwidth cable may still show 4K at 240Hz, because DSC can compress the display signal and make a demanding mode possible even when the raw bandwidth is not enough. And to be clear, DSC is not automatically bad. It can look completely fine in normal use. But the point is that if your cable cannot provide enough bandwidth, the system may need to rely more on compression or lower link modes to make everything work. For example, 4K at 240Hz with 10-bit color with HDR on can need around 68 gigabits per second uncompressed. So this is a lot of data. With the Silkland DP80 cable, GBUZ shows 20 gigabits per lane across 4 lanes. So technically the connection has a full 80 gigabit DisplayPort link available. So when buying a DisplayPort cable for a high-end monitor, I would not only trust the title of the listing. A lot of cables say 8K, 16K, gaming cable, high speed, or DisplayPort 2.1. This word sounds good, but they do not always tell you the full bandwidth tier. The terms I would look for are DP80 and UHBR20. And even better, I would check if the cable is actually certified on DisplayPort website. For this Silkland cable I'm using here, the model is S1334 and you can also search for it on the official DisplayPort certification website. When you search the model there, it appears as a 2-meter DisplayPort 2.1 cable rated DP80 UHBR20. I also checked Silkland on product page and it shows the same main points: DisplayPort 2.1, 80 gigabit per second bandwidth, VESA certification, 4K, 240Hz support, HDR, and support for high-end gaming monitors. So here, the three checks match. The product page says DP80, the official certification page shows DP80, and GBUZ confirms the connection is actually running at 20 gigabits per lane, so 80 in total. Now moving on to the cable itself, the connector housing has an aluminum alloy shell and the cable is nylon braided, so it feels more durable than a basic rubber cable, and it's 2 meters long. Silkland also offers the same type of this cable in different length options, which is useful depending on your desk layout. But at the same time, I would not just buy the longest cable possible for no reason. With high bandwidth display cables, length can matter. The longer the cable, the harder it can be to keep a very high bandwidth signal stable. So personally, I would choose the shortest cable that comfortably fits the setup and make sure that the exact length is certified for the speed. During gameplay, I did not notice flickering, black screens, or signal drop. So for this setup, that is exactly what I want: a stable connection that lets the monitor run the way it is supposed to, without relying on DSC. So to make it simple and brief, not everyone needs an 80 gigabit per second DisplayPort cable. If your monitor does not need that much of bandwidth, you can use something similar and be completely fine. But if you are using a high-end monitor, especially something like 4K at 240Hz refresh rate, then the cable is definitely worth checking. So before buying a random DisplayPort 2.1 cable, I will check three things. First, check the real bandwidth tier. If you are aiming for the highest DisplayPort 2.1 cable bandwidth, look for DP80 or UHBR20. Second, check the certification. Do not only trust words like 8K, 16K, gaming, or high speed, especially if the cable is not certified. Search for the exact model on the official DisplayPort certification website if possible. And third, after connecting it, check the actual link speed in GBUZ, which is actually a free software. If you see 20 gigabits per second for bandwidth and 4 lanes, then you know the connection is running at the full 80 gigabit level. So for this Silkland S1334 cable, it's listed on the official certification database, and in my taste, it runs a full 20 gigabits per lane. And now I'm curious to know, have you ever had a monitor that did not show the refresh rate or resolution you expected? Or maybe you had flickering, black screens, or random signal loss, and it ended up being the cable? Let me know about your experience in the comment section below, and I really hope that you found this video helpful. If you did, please leave a like, subscribe to the channel. Thanks a lot for watching, and I'll see you in the next one.